Problem number 8 says to find the z-scores for which 96% of the distribution's area lies between negative z and z. We know the area or the probability, and we are essentially working backwards. We're in a standard normal probability distribution. Therefore, our mean is going to be 0. And we need to know what this value negative z is and what this value positive z is, for which 96% of our distribution lies. The area in between these two z values is 96%, or 0.96. Now, since the standard normal distribution is symmetric, the area that is over here to the left and the area that is over here to the right, those are equivalent to each other. They're equal. In order to find this z value, remember that our standard normal probability table tells us area to the left. To find this z value, we need to know the area to the left. That would be this area here. So if we know this area, then we are able to find out what our z value is. And due to symmetry, the z is going to be the same. One will be negative and one will be positive. The way that we figure that out is we know that the whole area has an area of 1. 1 minus 0.96 is 0.04. And since there's 2 of them, we are going to have to cut that in half. Half of 0.04 is 0.02. We know that this side is 0.02 and this side is 0.02. If we add each of these areas or probabilities up, they will add up to 1. Now we need to go to our standard normal probability table and look for 0.02, or the closest value to 0.02. 0.02 is going to be between 0.0202 and 0.0197. It's closer to 0.0202, therefore that's the one we're going to use. We look over to the left, the very first column, that tells us our ones and our tenths place, negative 2.0. And then we look up to the top of our column for our hundredths place, 5. Therefore, our z is going to be negative 2.05. And this one is also going to be positive 2.05. You could also find this one if you wanted to. The way you would do that is you would have to subtract 0.02 from 1, which would give us 0.98. So if we go to 2.05, we should be as close as we can to 0.98. And in fact, that is the value that is the closest to 0.98. It is between this one and this one, and it's closer to this one, which is 2.05.